Welcome to the presentation of this vision paper, which is a collaboration between myself, Zsolt, and Soujanya and Vijay. I don't think I need to motivate too much why we're interested in data protection regulation and being compliant with this regulation. As we all know, there are stricter rules being introduced in many countries and regions on how data is collected and processed by companies. There's a push for adding right to privacy to the guarantees that citizens get. And in general, we see a shift of responsibility away from the consumer and onto companies. And for many of us, for instance, people living here in Europe, there's already frameworks in place, such as the GDPR. But in other parts of the world, there's also emerging regulation. And going forward, it is reasonable to expect that most of the world's population will be under one regulation or another. So going forward, companies will have to invest more and more in policy compliant database systems. And of course, the good news for us as a community is that we have worked on many of the puzzle pieces required here. Of course, with one difference being that now there's a legal requirement for being compliant. I want to highlight that there's emerging works in providing compliance inside a single database node, but there's still an open challenge on how we can do this at the disaggregated architecture level, how we can handle large distributed systems in a policy compliant way. And I think the main clash here is between the need for compliance on the one hand and the additional operations that this introduces, and the need to process ever increasing data sizes at an ever increasing speed on the other hand. And what we do in this work is to explore the question of how we could provide compliance without incurring a slowdown on the processing side of things. And to scope the problem a little bit, so what we look at here is in a distributed data processing system, we are interested in exploring the cost of the policy compliance at the distributed storage layer and making sure that this is secure or this is compliant with the regulations that are relevant. And the threat model that we assume is that the company that is running this distributed solution is trying to do the right thing, but of course they have these nodes deployed in the cloud or in a data center and cannot guarantee that the nodes will not be tampered with at some point. They also have no guarantees that the applications will not be faulty or malicious. However, what we assume is that they have some sort of trusted controller that can be used to bootstrap and manage this distributed storage layer. So very good. So far, I have told you that policy compliance is increasingly important, and we looked at the fact that most of the data processing systems are massively distributed. Now, the question is compliance really a problem? Does something like the GDPR really affect what the storage nodes have to be able to do? And the answer is yes, it does affect them quite a lot. So what you see on the left is a series of GDPR articles that are relevant for how data is stored, accessed, and managed within the distributed storage layer. And on the right-hand side, I show the types of additional operations that have to be added to distributed storage to make sure that we can comply with the requirements on the left. And to illustrate this with an example, if we look at the standard key value store type of interface and the client reading data from a distributed storage node without any compliance, of course, this is a simple operation. We look up the key in some index and return the value. But if we need to enforce policy compliance, then suddenly there's a lot of additional operations that we have to do. So for instance, we have to encrypt and decrypt data depending on various rules, and we have to manage the keys and the crypto material needed for performing these operations. We have to authenticate clients and make sure that they have the right permissions. We have to log operations and make sure that we can make sense of these logs and detect when something has gone wrong. And there's perhaps more and even more involved operations that have to be done. So overall, it's clear that compared to just a simple, naive distributed storage solution, providing one which is policy compliant is quite challenging. So what our goal is to explore how we can use emerging smart storage solutions think of it as network attached disaggregated flash, in order to hide the cost of policy compliance. And what makes these smart storage nodes interesting is that they typically incorporate some form of programmable logic, FPGAs, which you can think of as reprogrammable hardware devices that provide high performance pipeline processing, which matches network facing operations quite well. They have a different trade-off from general purpose processors in that you can provide additional functionality at the cost of space and not time. And they have, in general, a predictable behavior, which is a plus for any distributed storage. And what is interesting here is that given these benefits of specialized hardware, programmable devices, we could actually reimagine the way many of these policy compliance related operations are performed and do them at the network line rate. So in effect, hiding their cost. But there's a challenge. These devices are not well equipped and are not efficient when it comes to taking complex decisions. And these kind of decisions are necessary to manage, for instance, the crypto material for encryption or the permissions of different clients and so on. What we propose in our vision paper is a software-defined approach to this problem where enforcement can happen in a specialized hardware node, but decisions are carried out in a general purpose software environment. And to go through the example from the previous slide, the controller can manage app permissions and their keys, for instance, whereas the enforcement layer takes care of encryption and decryption at the line rate based on the keys that has been loaded by the controller. And the way the two layers interact is at the heart of our SDP vision, which is a simple table-oriented interface that allows the controller to decouple the high-level logic of policy compliance from the low-level operations that the enforcement layer has to do to decrypt, encrypt, authenticate clients. As we show in the paper, this design is quite flexible and can be adapted to different specific data protection regulations, such as the GDPR. While I don't really have time to go into details, let me just give you a high-level overview of how the hardware side of things might look like in an SDP vision. So what I'm showing here is a hardware pipeline of operations, where, as you can see, each stage corresponds to the types of operations that you have to perform for policy compliance. And on the right-hand side, what you see are a series of tables that basically define the behavior of the left-hand side pipeline. And these tables are the interface that I already mentioned between the controller and the hardware. And this is the interface that decouples the implementation of the two. And the good news here is that using state-of-the-art hardware modules, we can almost implement everything on the smart storage node side of things. And the main remaining challenges are actually on the software side in the controller. So for our vision to work, we will of course have to come up with a way of converting all the way from a high-level description of laws or regulation to SDP tables. But what we think is promising is there's actually related work in this space already focusing on single databases, and we believe that there is a good chance that this can be expanded to the SDP vision. So the other related remaining challenge is in providing trusted execution environments in specialized hardware nodes in the cloud. And this is needed because our vision actually hinges on being able to make sure that once powered up and configured, our storage nodes are trustworthy. And the good news here again is that there's more and more solutions for trusted execution environment built with FPGAs or accelerated with FPGAs appearing in the cloud. And we believe that in the very near future, we'll be able to incorporate these trusted elements inside smart storage nodes as well.
To conclude, I talked about the importance of policy compliance at the storage layer and presented our vision for achieving compliance without reducing the performance of applications running on top of the distributed storage layer. There's a few remaining challenges, namely in the software controller and in providing custom trusted execution environments in the cloud, but these are not fundamental and can be solved in the near future. Perhaps the biggest remaining challenge is about reasoning about data movement once it leaves the storage layer, and this is something that we are definitely interested in chatting about at the conference. With this, I thank you for your attention and I'm open for questions.